Okay, we're going to talk about section 5.6, which is the fundamental theorem of algebra. We're going to use the fundamental theorem of algebra to solve polynomial equations with complex solutions. The main thing is when we have a quadratic equation, I'm just going to start with the quadratics. Let's look at this. A quadratic can cross a graph twice, like this graph does. It can cross one time right here or no times when we look at the equation. So as we look through these equations, we're going to look for all solutions. Now what the fundamental theorem of algebra says, it says a polynomial p of x is a polynomial of degree n greater than 1, then p of x is equal to 0 has exactly n roots, including multiple and complex roots. That means all the imaginary, all the real, and all those put together would equal the total of the highest exponent. So on this example, it says here it has a degree 5. That means there is 5 roots in this example. And so what I did start it off with is writing down my p and q. Now our rational roots would be p over q plus or minus 1, plus or minus 2, and plus or minus 4. Now what we need to do is find our roots. And I'm going to start with a number which I think might work out here. Let's try 1 first. So we're going to do 1. And then we're going to have 1, -1, -3, 3, -4, and 4, since it's already equal to 0. So then we're bring down the 1. Is 1, which is 0, which is 0, which is a -3, which is -3, which is 0, 0, -4, which is -4, and 0. Pen went off a little bit there. Let's finish that up. -3 is a -3, which is 0, which is 0, which is a -4, which is a -4, which is 0. Okay, so it worked. So I know one of my roots is 0. So now what we know, we started with x to the 4th here. We can break this down to x to the 4th, no thirds, minus 3x squared minus 4. And now we can use some factoring methods on here. Sometimes it works and sometimes it doesn't. Now if I tee this up, we can go x to the 2nd and x to the 2nd. And this would factor down to a -4 and a +1 to make the -3 I want to. So this would be down to x squared minus 4, x squared plus 1. This would be x, if I solve this part down right here, it would be x minus 2, x plus 2, then x squared plus 1 equals 0. So we have an answer here of x equals 2, x equals a -2, and then over here we get x squared equals a -1. Take the square root of both sides. We're going to get x equals plus or minus I. So our highest exponent is 5. So we got 2 answers here, plus or minus 5. We have an answer of 2, we have an answer of -2, and we have an answer of 1. So we have 5 different answers as we go through. So some different ways to look at finding the answers. So here's another problem here. It says x to the 4th minus 2x cubed equals 13x squared minus 10x. Now if we factor out, we can have x to the 4th plus 2x cubed minus 13x squared plus 10x equals 0. Can't solve it down unless it's equal to 0. So the first thing I'm going to do on this one is factor out of x. We always do that first. So we're going to x cubed plus 2x squared minus 13x plus 10 equals 0. Now we're down to x cubed. Now we can't finish this off any as we go through, so therefore we might have to do our P over Q. So our P is 10. So we got 1 and 10, 2 and 5, and the negatives. Our Q, I'm going to put the Q up here, off this equation, 1, 1. You notice I don't do that until I get a number down here. So possible rational roots here, plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. Now we have to find 4 roots. We already found 1 right here. We set that equal to 0. We're going to get 0 as an answer. And now the other one, we would have to find 1 more to get it down to x squared. So I don't know what number would be a good one to try. Let's try, I'm gonna write this part out in the synthetic part. So we're gonna have 1, 2, negative 13, positive 10. And over here we're gonna have our number. Let's try 2. Let's see what happens with 2. We bring down the 1. We're gonna have a 2, which is 4, which is 8, which is a negative 5, which is negative 10, which is 0. That was a good guess. So that one worked, so we know, but now we're down to x squared. Remember, we started with x to the third. Now we're down to x squared, so this is x squared plus 4x minus 5 equals 0. Now if we can factor this down to x plus 5, x minus 1 equals 0, so x is equal to a negative 5. X is equal to a negative 5. X is equal to 1. So now what are my answers? I got x equals 0. I got x equals 2. That worked. X equals a negative 5. And x equals 1. So I had 4 answers on here. Here's another problem. Now my hint to this one is set it equal to 0, do the P over Q, and start breaking it down. We're looking for 4 answers. I want you to do that one. Okay, now if we look at this, what are the turning point, what are the zeros of this function? Well, we would have to look at do the same rules that we did before. Now I just want to look at a few different concepts that might come back to this problem. It says the graph of x to the 5th plus 4 minus 3x cubed minus 12x squared is shown at the right. Use the turning points to explain why the graph does not show the real zeros of the function. Well, if this is x to the 5th, it means it has 1 less, so it's going to have 4, 2, or 0 turning points. Always 1 less than that. So if I look at this, I got 1, 2, 1, and then 2, then 3 turning points. 3 is not one of our options, so it has to be 1 more than that. So therefore, this part of the graph has to come back down, or this part of the graph has to come back down. So with the turning points, remember, it's always 1 less than the number of exponents and 2 less from there. So this is 4, 2, or 0 turning points. This one had 3 shown, so there has to be 1 more. Now the graph of g of x is equal to this graph plus 4. Is the translation of the graph of f up 4 units. How many real zeros of graph will g show? How many real zeros of g will the graph show of g show? Okay, if we move everything up 4 units, this is going to be moved up 4 units. Right now it's at, let's see, this is negative 8, this is negative 4. So this is still going to come below, up, and this is going to go up 4 units. It looks like it's going to touch there. This one's still going to be below 0. So how many real zeros is this going to show? This is going to be imaginary 0. So I'm going to say it's going to cross once here. It's going to cross, come up here once, and it's going to have another one. I would say 3 times it's going to cross. And there will be 2 imaginary. Here are the equivalent ways to say the fundamental theorem of algebra. You can use any of these statements to prove the others. Every polynomial equation of degree n greater than or equal to 1 has exactly n roots, including multiple and complex. every polynomial degree n greater has n linear factors, and every polynomial function degree n greater than or equal to 1 has at least one complex zero. So what we're doing here, just remember, you got this problem down here to do, here, and for extra credit, if you want to find me the zeros of this equation, you could do that too. Thank you.